Hi, future doctors. Welcome to the next class. In this class, we'll see mutual induction and self-inductance is acting as EMF. What is its direction? It is a coil of self-inductance L. Now, in this, I current is passing. If this current is increasing, then how much EMF is developing already we discussed E is equal to minus L di by dt. This di by dt rate of current is going to be increasing, they will give. At the time how this EMF, this inductor will be acting as a cell, how it is going to act means like this. Now same coil they will give, same current direction, they will give this current is going to decrease, decreasing. At the time it will be coming like this. So in solving problems it is going to be very important. So Kirchhoff's laws we discussed. In Kirchhoff's laws we have done this type of problems. This is B, this is A, 2 ohms, so 5 volts, 10 volts, 1 ohm, 2 amperes current is passing. Then what is the potential difference between A and B? At the time, ideal cell we assume, in current LCT we discussed this. So we have closed this loop like this. So we are going in the direction of loop. Current is also passing in the same direction. So both are in same direction means potential difference we have to take negative. We will be starting with A. VA minus 2 into 2. 4. Both are in same direction, therefore minus 4. Next, here cell is from positive to negative. Positive to negative means we discussed minus 5 volts. Next, loop is going like this, loop direction. Current is also passing like this. Therefore, 2 into 1 minus 2. This is negative to positive. Therefore, plus 10 should be equal to VB. Then, if we solve this, so 5 minus 5 minus 2 minus 7 minus 7 minus 4 minus 11. So VA minus 11 plus 10 equal to VB. Minus 11 plus 10 minus 1. So minus 1 is going that side. So VA minus VB equal to 1 volt. Now in place of this, any one battery they may give like this. Same question I am doing, small change. Just you have to observe. 2 ohms. Now they will give inductor 2 millihenry or 2 henry, like that they are going to give. So 2 henry you can take, or 2 millihenry, microhenry, they wish. And another same 1 ohm, another one is that. Again, what is the potential difference between A and B? So while giving this current 2 amperes. This 2 amperes is increasing di by dt, increasing at the rate 1 ampere per second, 2 ampere per second, like that they are going to give. At the time, how you have to solve means, now this circuit we have to convert like this very easily. How they are going to, how they are going to give, if it is going to be increasing, current rate of change of current is increasing 1 ampere per second. How this is going to be changed means 2 ohms. Now this inductor I current that is going to be 2 amperes is going to increase the gain. Whenever it is going to increase, what we said, increasing means like this, same as it is like this. So L value E, this is 1 ohm, this is this E, 10 volts. Same problem, small change. Okay. Now current direction 2 amperes we give. Same current you can take 2 amperes, 2 into 2. Same direction. Current is going like this, loop is also going like this. Same direction loop. Same problem. Just in place of this, we gave inductor. Now, positive to negative is there. Positive to negative is there means what we have to write? Positive to negative is there means we have to write minus E. So, minus 2 into 2, VA, minus 2 into 2, minus E, minus 2 into 1, this is plus 10 equal to VB. What is this minus E? E is equal to L di by dt. What is L here? 2. Therefore, VA minus 4 minus what is L? 2. What is di by dt? 1. So, minus 2 plus 10 equal to V. If you solve this, you are going to get the answer. So, this is you have to follow. If current is increasing, battery symbol you should take like this. If it is decreasing, you should take like this. Once you have taken battery here, same process in current electricity what we discussed. Therefore, you can practice some problems, definitely you can understand and you can do. Now, you will see mutual inductance. Self-inductance means in the same coil current is changing, flux also changing in the same coil. But mutual means current is changing in one coil, flux will be developing in another coil. That small change you have to remember carefully. So, this is a coil, its radius is going to be R1. Now, another coil I am taking, its radius is going to be R2. Now, current is passing in second coil, I2 you can take or I1 you can take, that is your wish. Because R2 I am taking, I2 I am taking. Now, whenever current is changing in second coil, flux is going to be developing in first coil, because around the current what will be developed? Magnetic field. That magnetic field is changing in secondary coil this much area, smaller this area, within this area. Whenever it is changing, here what will be developed means flux is going to be developed. Here current is changing in second coil, I2. Flux is developing in first coil. So, phi 1 is directly proportional to I2. If it is having n number of turns, n1 we are going to take. So, if you remove proportionality constant, we will write m I2. Same like that, if current is passing in first coil, then n2 phi 2 is directly proportional to I1. So, n2 phi 2 is equal to m I1. So, what is self-inductance we wrote? Self-inductance is N phi is equal to Li, because current and flux is changing in same coil. But here it is not like that. Current in one coil, flux in another coil. So, then M is equal to N1 phi 1 by I2 from this. From here, N2 phi 2 by I1 we can write. Next, induced EMF. Whenever induced EMF is directly proportional or is equal to minus d by dt of phi. So, minus d by dt of, so induced EMF is changing in first coil, therefore N1 phi 1. This is first coil. Now, E1 is equal to minus d by dt of, in place of N1 phi 1 what we can write? M I2. So, E1 is equal to minus M di2 by dt. So, current is changing in which coil? Rate of change of current in secondary coil, induced EMF developing in first coil. So, but in self-inductance E is equal to minus L di by dt. Rate of change of current in same coil, induced EMF also same coil. This small difference you have to understand. Therefore, we will say that is mutual inductance. They will give rate of change of current, time, induced EMF they will ask. Sometimes they will ask mutual inductance. Same units, same dimension formula you are going to get. How, if you want to write dimension formula, M is equal to E into dt by di if you multiply. Induced EMF means voltage. What is the voltage dimension formula? V is equal to W by Q. M L square T power minus 2 by AT. So that is EMF. So M L square T power minus 2 by AT. Now dt means time. Di means current. A. So you can divide this. You are going to get mutual inductance dimensional formula or self-inductance. Both are going to give Henry dimensional formula. Both are going to give same answer. Now, for solenoid, what is this? Mutual induction. We are going to get. How easily we can remember means, so here two coils are there. So one coil radius R1, another coil radius R2. Isn't it? What is the self-inductance of solenoid we got? Mu naught n square A by L, capital N square. Small n square means mu naught n square AL we got. So just in place of n square, you are going to get n1, n2. M is equal to mu naught n1 n2 A by L. Both the lengths are going to be same. Now which area we have to take? So area is going to be taken always smaller area. That one you should remember blindly. Mu naught n1 n2. The smaller area is nothing but pi r1 square. Because flux is changing. Whenever current is passing through this, flux is changing within this area. If current is passing through this, flux also will be changing in the same area of this bigger coil, because flux will not travel outside if current is passing in smaller coil. Therefore, area always you have to take blindly. You can remember which is their smaller area, that area we should take. So without derivation, just I am giving small n is there means small n1 n2 AL. Again, which area we should take? Mu naught n1 n2 pi r1 square L. For this diagram, this is going to be correct. If you want to derive means, you can derive like yesterday n phi equal to BA, like that we can take. But derivation is not required, already we derived for this. Directly we are writing. Next, if you are taking coils like this is R1, this is R2. If current is passing in this coil, which coil? Secondary coil, which is having radius of the coil I2. Now, what is the mutual inductance between these two? They are going to ask. At the time, whenever I current is passing, what is the magnetic field at center of this coil? Means B naught is equal to mu naught I by 2 R2. That is the magnetic field due to secondary coil. Now, flux is changing within this area. Therefore, phi is equal to only one term we will be having. Phi is equal to BA cos theta. So, magnetic field is outside, because current is passing like this means thumb is representing outside. So, this area is also outside. Therefore, BA cos 0. Now, what is B means? Mu naught I by 2R2. What is A means? What is the area of this? Pi R1 square. This is phi. This phi you have to equate for Mi. So, I will be cancelled, because N is not there, only one term we are taking. Therefore, M is equal to mu naught pi R1 square by 2 R2. If current is passing in bigger coil. Now, same question they have given, current is passing in smaller coil. This is going to be R1, this is going to be R2. Now, current is passing in smaller coil. So, now what is the magnetic field at center means? So, B naught is equal to mu naught I by what we have to write? 2R1, because current is passing in R1. Here we wrote 2R2 because current is passing in R2. Isn't it? Visible. Now, again, flux will be linking with only this area. It will not go for this. Therefore, phi is equal to, again, BA, directly I am writing, BA cos 0 is 1. So, what is B we wrote? Mu naught I by 2R1. Which area we should take? Always we should take smaller area. That is going to be pi R1 square. Now, R1 will be cancelled. So, mu naught I pi R1 by 2. This is going to be flux. This flux we have to equate for MI, mutual inductance. So therefore, I if you remove comparison, M is equal to mu naught pi R1 square by 2. See the change. So always we have to take which area I told you? Smaller area we are going to take. So by using this formula, wherever n square is there, you will write N1, N2 because two coils are there in mutual inductance. Self-induction, only one coil, therefore n square. So small n, number of turns per unit length. Whenever small n came, N1, N2. So area always you should take smaller area. So this is about mutual induction. Okay.